Okay, so this lesson is going over trigonometry. So trigonometry is the study of basically angles and sides in right triangles. Actually, they don't have to be right triangles, but we're going to focus on right triangles. Trigonometric ratio is a ratio of the lengths of two sides of a right triangle. So for instance, one trig ratio of this triangle might be AC over AB. So ratio, remember, is just a fraction comparing numbers. So AC over AB would be considered a trig ratio. Okay, so again, we're focusing on right triangles. So here we have a right triangle, triangle ABC. The 90-degree angle is angle C. So then angle A and angle B are both acute angles, so angles less than 90. So the sine ratio, if we have triangle ABC, it's a right triangle. The sine of each angle, acute angle, is the ratio of the length of the leg opposite to the angle to the length of the hypotenuse. Okay, so if we're looking at angle A, and that is what we call the reference angle, that's the angle that we are using, sine A would be equal to the opposite side, which would be A over the hypotenuse, which would be C, so A over C. If we switch the reference angles to angle B, the opposite side now is B, and the hypotenuse still remains C. So sine of B would be B over C. The cosine is the ratio of the adjacent side over the hypotenuse. So adjacent means the side next to the angle. So again, if we're looking at angle A, the adjacent side to A is side B. The hypotenuse would be C. So cosine of A would be B over C. And then if we switch our reference angle to angle B, the adjacent side becomes side A. So cosine of B would be A over C. Notice that your hypotenuse never changes. It's always across from your right angle. Okay, the third trig ratio is tangent, and the tangent ratio is the ratio of the length of the leg opposite that angle to the length of the leg adjacent to that angle. Okay, so if we're looking at angle A, the opposite side to A would be A. The adjacent side would be B. So tan A would be A over B. If we switch reference angles to angle B, tan B would be B over A, because B now becomes the opposite side to angle B. If we use similarity, we know that that ratio, as long as the angle is the same, because now these triangles are all similar by angle, because they have the 35-degree in the angle. As long as the reference angle stays the same, the ratio is always going to stay the same. All right, so now let's take a look at an example here. So here we have a right triangle, and they're asking us to find sine, cosine, and tangent of both of the acute angles. They want us to express each ratio as a fraction and as a decimal to the nearest hundredth. Remember, hundredth is two numbers after the decimal. Okay, so let's first look at angle J. So using angle J as our reference angle, I'm going to label my sides. Well, 13 I know is my hypotenuse. 12 is the side that is closest to the angle, so that's my adjacent side, which makes 5 my opposite side. All right, so sine we know is opposite over hypotenuse, so that's going to be 5 over 13, and I'll get the decimals after. Cosine is adjacent over hypotenuse, so adjacent is going to be 12 over 13. And lastly, tangent is opposite over hypotenuse, so it's going to be 5 over 12. So now we're just going to get those decimals. So the first one is 5 over 13. So to the nearest hundredth, we would say 0.38. Then we have 12 over 13 for cosine. That's 0.92. And then we have 5 over 12. So in this case, we are going to round this up because the number after the 1 is a 6. So we're going to put 0.42. Okay, so now let's change our reference angle to K. So I'm going to switch colors. So K is now our reference angle. I'm going to relabel my sides. Well, we know 13 stays the hypotenuse, but 5 now becomes my adjacent side because it's the side closest to the angle, and that means 12 would be my opposite side. All right, so starting with sine of k, we know sine is opposite over hypotenuse, so it's going to be 12 over 13. Cosine k is adjacent over hypotenuse, so it's going to be 5 over 13. And lastly, tan of k is opposite over, oops, sorry, this should say opposite over adjacent over here. Tan of k is opposite over adjacent, so it's going to be 12 over 5. All right, so now let's get the decimals. Well, let's see. We actually have 12 over 13 already over here, so that's going to be 0.92. And actually, we have 5 over 13 over here, 0.38. So that's not a coincidence. So let's think. The only difference between the sine ratio and the cosine ratio is the numerator changes from opposite to adjacent and vice versa. Well, let's think. When we switched from j to k, the opposite and adjacent angles switched. So these ratios should always be the same. Cosine of j should always equal sine of k, and sine of j should always equal cosine of k. And if you notice for tangent, we just took the reciprocal. It was 5 over 12, opposite over adjacent, but when we switched reference angles to k, it became 12 over 5. Again, that's because the opposite and adjacent sides switched. All right, so let's do 12 divided by 5. It's going to be 2.4. Okay, so let's look at another example here. Now, we'll get into a little bit more practice with this later, but we can use trig to solve for missing sides. So far we know how to solve for missing sides using Pythagorean theorem. We know how to solve for missing sides using special right triangles. However, we know we can only do that in certain cases. So in this case, let's look at the information. So it says, Matthias builds a ramp so his sister can access the back door of their house. The 12-foot ramp to the house slopes upward from the ground at a 4-degree angle. What is the horizontal distance between the foot of the ramp and the house? And what is the height of the ramp? Okay, so let's fill in the information we know. We know the ramp is 12. Well, here's our ramp. So the ramp is the part that you actually are going to go on. So this is going to be 12 feet. And then they say that the angle from the ground is 4 degrees. So this angle right here is 4 degrees. Okay, there's two measurements we're solving for. We were solving for the horizontal distance between the foot and the house. That's going to be this bottom side here, so we'll go ahead and call that x. And then we're also solving for the height of the ramp, which we can call y. Okay, so if we think about the things that we've learned so far, we cannot use Pythagorean theorem for this problem because we don't have another side. We also cannot use special right triangles because this is not a special right triangle. Okay, here's our 90-degree angle. So that means we're going to have to use trig. Okay, so for the reference angle, you have to use either one of the acute angles. Well, since we have this one, let's use this as my reference angle. And I'm going to label my sides. Well, I know that 12 is my hypotenuse. X is going to be my adjacent side, and y is going to be my opposite side. Okay, so let's solve for x first. Well, x is my adjacent side, and the only other information I have is my hypotenuse. So that's the a and the h, which tells me that I need to use cosine to set up this ratio, since we know that cosine is adjacent over hypotenuse. So it's going to be cosine, then we're going to put the angle measurement, and then it's going to be the adjacent side over the hypotenuse. So it's going to be x over 12. Okay, let's just see what we would do to solve for y. Well, y is my opposite side, and I have my hypotenuse. So that's O and H. We would use sine to solve for that one. So sine of 4 degrees is equal to y over 12. So now it's just a matter of solving. Well, let's see. Cosine of 4 is equal to x over 12. If we want to get x by itself, we got to multiply by 12. All right, so then we have 12 times cosine of 4 degrees is equal to x. So that's what we're going to put in our calculator. Okay, so using the Desmos calculator here, we're going to do 12 times cosine of 4 degrees. 11.97. right, let's look at sine. Let's do the same thing. So we're solving for y, so we need to multiply by 12 to get y by itself. So that means y is equal to 12 times sine of 4 degrees. So again, this is what we're going to put into our calculator. And then just keep in mind, you might be thinking, wait, this is the same thing, but this is cosine and this is sine. Those ratios are totally different. So 12 times sine of 4 is going to be 0.84.